שלום לכולם, ברוכים הבאים. אני אוהד, וזה ארתור. שנינו עובדים ברדאט, אני עובד כמי שיצר את כלי שנקרא פורמן, וכיום מנהל את הפיתוח שלו. וארתור.
אני ארתור ברזין, מנהל מוצר ברדאט, עובד בעיקר על רכיבי התשתיות באופנסטאק.
אוקיי, אז לפני שנתחיל, שתי שאלות. כמה מכם מתעניינים ועוסקים באופנסטאק כתשתית? זאת אומרת, מתקינים את אופנסטאק, משתמשים בו, וצריכים לפתור את הבעיות היומיומיות שלו. סבבה, נהדר. כמה מכם עובדים עם כלי ניהול, כמו פאפט, שף? אוקיי, יש פה משתמשי פורמן, אנשים שמתעניינים בפורמן? גם? אוקיי, סבבה. יופי, אז יש לנו מישמש נחמד, תרגישו חופשי לשאול שאלות, אם יש זמן בשמחה, אם לא אז אחר כך. יאללה, בוא נתחיל. טוב. לחצי, אני אעמוד.
טוב, אז כל משתמשי פורמן, משתמשי פאפט, משתמשי שף. להתקין אופנסטאק, אתם ודאי יודעים, זה לא משימה של חתול קטן, זה משימה של אריות, ואנחנו יודעים שזה לא טריוויאלי ולא קל. כולנו מכירים את הדיאגרמה הנורא נחמדה הזאת, כולנו התפסנו אותה, שמנו אותה על הלוח, אמרנו, רגע, שנייה, איך זה מתרגם לשרתים הפיזיים שלי ולסביבה שלי, והגענו למסקנה שבמציאות הנחמדה שלנו, כאילו, המציאות היא הרבה יותר מסובכת מכמה שאנחנו מצטרים אותה על הדף, וזה fairly complex mission to accomplish, מה שנקרא. ככה, אז מבחינת deployment של OpenStack, אני לפחות בתוך בעולם OpenStack, התחלתי בערך עם דיאבלו SX, ובזמנו בעצם היינו מתקינים OpenStack מפקג'ז. אז היינו מתקינים את הפקג'י עצמם, את ה-RPMים או את הקיצי דב באובונטו, היינו מקנפגים הכל ידנית, מקנפגים את הסרוויסים, נכנסים לכל הקיצי קונף, דואגים ל...
להגיד אובונטו.
לא, מוטב. כולנו חברים.
אנחנו קומיוניטי אחד שמח, אז כולנו עובדים על אופנסטאק והכל בסדר. אז היינו מקנפגים את הסרוויסים עצמם באופן ידני, היינו מתקינים את הדאטאבייס, מתקינים את המסאג' ברוקר, מחברים את כל הסרוויסים, עושים הרבה עבודה ידנית, ואז היינו עושים סרוויס סטארט להכל, והם מבינים שזה לא עולה ולא מנגן, ואין לי הורייזן ואין לי API. היינו מתחילים לאט לאט לדבק, להבין מה שבור, היינו מנסים לאט לאט לתקן סרוויס ביי סרוויס, וחלקנו היינו מתייאשים, אני הרבה מהפעמים התייאשתי לפחות, ולא עמדתי נואש, ואז בעצם הגיע פקסטק. כמובן שחסר שלב בין פקסטק לפקג'ז, בעצם זה אותו שלב של הפאפט מודולס, או השף קוקבוקס. אוקיי? אז בעצם פקסטק זה ראפר מסביב לפאפט מודולס, אוקיי? שהוא בעצם עוזר לי, אני לא חייב לדעת לעומק, ממש לעומק, פאפט בשביל להתקין אופנסטאק. אוקיי, פקסטק זה בעצם רפר מסביב לפאפט מודולס. אני יכול לייצר, לג'נרט לי איזה קובץ answers קצר כזה, להיכנס ל-MVI לתוכו, לערוך, להגיד, אני רוצה את הסינדר שלי עם האסקאזי, אני רוצה את הקיסטון שלי עם טוקן עם UUIDs נגיד, במקום טוקנים של UUIDs, יש לנו שתי סוגים של טוקנים לקיסטון. UUID? לא זוכר, לא משנה. קיצור, אני יכול לקנפג את הסביבת אופנסטאק שלי, כל הדיטלס אני יכול לקנפג בתוך הקובץ קונף הזה, ופשוט להריץ פאפט עם answers file, אוקיי? פאקסטאק בעצם רץ על כל השרתים, מתחבר אליהם, מריץ פאפט, עושה פאפט agent-t, ובעצם מריץ את הריצה של הפאפט ומתקין את כל הסרוויסים. אוקיי, אז בעצם פקסטאק זה ראפר מסביב לפאפט מודולס, לאפסטרים פאפט מודולס. עכשיו, כולנו אוהבים פאפט וזה עובד וזה נורא נחמד. הבעיה שבעצם, ברגע שאנחנו עובדים עם פקסטק ועובדים עם פאפט מודולס במקום מרכזי אחד, זה לא רובסט enough. יש לנו סביבה שאנחנו צריכים לנהל, יש לנו לייפסייקל שאנחנו צריכים לנהל. יש לנו גרסאות שאנחנו צריכים לעדכן, סביבה שאנחנו צריכים לעדכן אותה מהוואנה לאייסאוס וכן הלאה וכן הלאה, וזה בעצם, כן, ראינו את הקומפלקסיטי של הדאטה סנטר שלנו. אנחנו מתחילים ממקום מאוד מאוד מסובך, וזה רק הולך ומסתבך. אז פקסטק זה כלי מאוד נהדר להתקין התקנות קטנות, ובאמת לעשות POCs, לבדוק מה שנקרא to kick the tires בסביבת אופנסטאק כלשהי, ובעצם להתקין את הסרוויסים, לקנפג אותם, אבל ברגע שאנחנו צריכים לגדול למשהו הרבה יותר רובסטי ופרודקשן גרייד, ולדאוג שאנחנו תמיד יכולים לנהל אותו, כלי שיותר מסובך לעבוד איתו. אוקיי, ואז בעצם עשינו אינטגרציה השתמשנו בפורמן, ועשינו אינטגרציה עם הפאפט מודולס ועם המשתנה סביבה, עם הדברים שבעצם כל מה שצריך בשביל להתקין OpenStack, עם...
Do you mind if you shift to English
Oh.
when it comes to this place?
Sure, yeah, sure, no problem. We asked before if there are any English speaking people.
OpenStack basic fundamental.
So once I say Foreman and then text second.
Thank you.
Okay, sure.
I would like to take advantage of this opportunity. Said that lunch will be at 1:30, so we have to finish at 1:30. Have lunch. If somebody is here, we continue after lunch. Lunch will be.
תשאיר זמן לשאלות אבל.
What we planned is 2 and 10 minutes. Okay.
All right. Cool. So I've just mentioned, we've just missed. I talked about installing OpenStack from packages and the problem with that. I discussed tech stack and the problems with that. And basically now I'm talking about our integration with Foreman. Basically what we ship is an integrated solution for deploying OpenStack using Foreman.
By our you mean RDO?
So RDO is our upstream version of OpenStack. That's basically just repackaging the upstream code. Okay, that's RDO, and we have OpenStack platform, which is our downstream product as Red Hat that we ship. Okay, so the upstream is basically the community version of that, the equivalent of Fedora, for example. So what is Foreman? What? Basically, you're the father of Foreman, so
Okay.
please tell us.
All right. So unlike maybe what we saw earlier about Tosca and maybe a very comprehensive and complex effort to actually define a standard, Foreman actually started completely the other way around. Foreman started as a data center automation infrastructure. Oops, can you tune the connector? It started as a data center management framework to simplify the guys who needs to operate and manage the infrastructure, simply simplify their life. Managing complex and infrastructure is pain. It's a lot of steps, a lot of manual steps, a lot of things that can go wrong at any point in time. And it basically started from pain and tried to alleviate that pain. And over time it grew and grew and tried to target and the life cycle management of infrastructure, in particular in the data center, in the cloud, in the virtualization realms, and so on. It mostly focuses about 3 components. The first one is provisioning. You can't create an application out of thin air. It needs to run on something. It needs to run either on bare metal. It needs to run on a VM, somewhere in the cloud, on a container. Somewhere it needs to run. So first of all, we need to solve the provisioning problem. The initial OS or container deployment or whatever it is, that needs to be there. Then the next part is basically, it's not enough to have an OS. It needs to have the right configuration. It needs to have the right things installed on it. Nothing will work without, the things that needs to have, the things that you need. And later on, there is a never-ending story to keep it running. Even in stateless instances running on a cloud where you don't care really, and it's a throwaway VM and you spin it back again, there's still state that needs to be maintained to some degree. The obvious example, if I have just a web server, he still needs to know where is my database. You still need to know some relationship between components. And today, everything is moving to a distributed framework where nothing is on one single VM or on single tool, even on multiple clouds. So really, that state needs to be constantly maintained. And we have 2 ends of things. We have the traditional OS state, packages, upgrades, security vulnerabilities, and the whole pain that OS management brings with it. And we have the actual configuration of the running services, and in some cases also the application itself that runs. So really, we try to simplify that, put it into a nice manageable web UI, and help the operator, the power user, or the API user, whoever it is, to build something greater on top of it. So this is in a nutshell Foreman, and we'll see a bit more as we go through the slides.
Yeah, and a great example is, so we all heard of Heartbleed, right? The vulnerability threat that we discovered recently. So, okay, we can reprovision all the instances, right? But wouldn't it be like a lot simpler just to deploy this single update to all my instances instead of redeploying my all my instances?
First of all, you have to know where are you vulnerable.
Yeah.
So first of all, how can you find in your infrastructure which services are vulnerable? You need a centralized asset management, something that you can query and give me back all of the list of servers that are vulnerable. Then you need to potentially perform an action to fix the vulnerability. And you can fix the vulnerability by spinning a new image and redeploying and hope that you can migrate all of your VM payload and all of that, or potentially upgrade the actual running operating system.
So going back to our nice little almost human being. So basically we're shipping a Foreman OpenStack installer, which is the pre-integrated solution for basically using Foreman and all needed Puppet modules to deploy OpenStack. That's shipped in RDO and in OpenStack platform as well. So that includes all the needed host groups, all needed Puppet modules you need to deploy OpenStack and configure OpenStack, and all the environment configuration for Pixie provisioning, for example. If you would like to have your provisioning network with DHCP, for example, they also can do that using the pre-integrated configuration that we're shipping. But the problem with that is you still have to know a little bit around Puppet, a little bit around Foreman, and obviously you still have to know which configurations to set in OpenStack configuration files, right? You still have to know which settings you would like to change in order to make a specific layout or to use a specific backend, for example. So we are introducing a plugin and basically a project internally at Red Hat we call Project StayPuff. Project StayPuff is basically a plugin that runs on top of OpenStack, and it brings functionality to deploy
on top of Foreman.
On top of Foreman. It brings functionality to deploy OpenStack very, very easily. So what is StayPuff? StayPuff basically is an intuitive deployment tool using Foreman, obviously. It's built for production-grade environments, for deploying production-grade OpenStack environments.
Yeah, the idea is really to take all of the best efforts and best practices we've learned from the huge Foreman community and huge Foreman deployments, and to try to focus that only in the use cases that actually make sense for OpenStack by providing a very specific OpenStack deployment experience.
So this is using the Puppet modules which are presented.
Right. Behind the scene, we're using Puppet modules. We're exposing a lot of, if you know the internals, but you don't necessarily need to. That's the whole point. Yeah.
Yes, we're going to see a screencast soon. So,
well, what's the problem with Foreman that it needs?
I'll tell you why. Take OpenStack itself. It's a giant set of services running in a distributed fashion. That means you have potentially, no one install a production OpenStack installation on 3, 5, or 10 servers. You usually have an OpenStack deployment. You install it on quite a lot of services, right? If you just need 2 or 3, 4 POC, it's a different problem domain than actually deployment of production environment. So there are so many permutations on how to deploy OpenStack. Example, which storage are you using? Which backend are you using for your storage? Which network driver, which providers and so on. And then are you running in an HA fashion or not? Which services are in HA? And HA for different services for database is a completely different set of HA for a controller. So there's so many permutations that people simply get lost. Unless it ends up being, I have to understand the entire architecture of OpenStack to get going. Yeah.
How do you compare it to Ubuntu Metal as a Service and Jupyter?
I think both. To be honest, I didn't use Juju that much myself. I think the main difference, and we haven't got to that point yet, so bear with us a bit, is that Foreman management does not end on deployment time. So Juju and other tools basically say goodbye when they finish, when the application initially runs for the first time. And here we are trying to give you a lifecycle management for the whole duration of your application, whether it's OpenStack or the guest application that runs inside OpenStack.
yeah, and it also takes care of not only the undercloud, the services themselves, the OpenStack services themselves, it also can take care of the overcloud, the instances. So, coming back to StayPuff, let's have a little feature rundown to see what's included within StayPuff. In addition, or basically how we configure Foreman to deploy OpenStack in addition to what Foreman already has to offer. So, we're shipping a live CD. You don't have to know how to install a RHEL or a CentOS server and then on top of that deploy Foreman or Red Hat Satellite or downstream product. Basically, you can just have this light ISO file, just boot it into a server, okay? And you just want to play with stuff. You just want to see how things work. You just want to make a POC environment and just run it for once or several times. So we've pre-integrated this live ISO. You can boot from it. It runs an OS with Foreman with Stave on top of it. You don't have to take care of anything. Everything is coming out of the box. You also have the option to install to local machine. So you take this ISO, okay, just boot from it. Just click on the install. It has everything needed pre-integrated with.
So overall, we don't want you to fiddle with stuff. We just want you to get productive as quickly as possible.
Exactly.
You can always dive in and learn the internals, but who cares? Let's just get going.
As long as it works.
What if I don't want to use Red Hat based distribution?
Sorry?
What if I don't want to use Red Hat based distribution?
You can rebuild the live CD for upstream Foreman, the so-called open source version. You can run with any operating system that you like. We don't force you. We actually have very great support for whatever. Ubuntu is obvious, and Spark, Solaris, and Windows, and SUSE, and the very long FreeBSD, and the list is very long. So you could, Red Hat invested time to create the live CD as a workable composable. There's nothing that stops you from tweaking that to Ubuntu live CD format.
All what we're talking about today is basically upstream projects. So you can always just git clone and make your own builds if you'd like to use it on a different distribution, for example.
Yeah. Okay.
Right. So I mentioned the live CD boot. I also mentioned the install to local disk. Also, Foreman comes with the host auto discovery feature, and what we're doing here with Stable is basically we're pre-integrating the environment to use basically to enable auto discovery of new hosts in the environment.
Using Pixie?
Yes. So for bare metal, yes, you have to.
So you have several options to add hosts to Foreman, basically. One is to have them manually registered. So you install an OS by your own, and then you just register to Foreman. And the other is to use the auto discovery feature. Just Pixie will just have the environment in the provisioning network, and the Pixie boost.
Run disk file system.
Right. Right. Yeah. So remember, the goal here is to make you get to OpenStack production grade quickly. So the more steps we can save you in the way, the happier you'll be.
Yeah.
Ideally.
I'm waiting for the network configuration.
Okay.
Yeah. So we have this environment. We have those hosts. They are not currently deployed with anything. We just say we want those three to be our HA controller, and all the rest would be our compute nodes. So all the nodes just Pixie boot from the network. Pixie boots the light image, and what this light image does is basically registers this host to Foreman. So after those three just booted to this live CD, Foreman is familiar with them and knows them. And what you can do from this step is basically to allocate them to host groups. Now we also have a new. Basically, this plugin brings a new user interface that helps you configure an environment specifically for OpenStack fairly quickly. So that's obviously a web UI.
You want to do the demo?
We have a little video demo of it.
Let me.
Ruin the surprise.
We'll start again.
Very fast.
It's that fast. It's that fast and no. Hold on. I'll start from the beginning. I'm challenged to do it on the left side. Okay. Okay.
It's not the beginning.
It's not the beginning. Okay.
So yeah. So you log in the environment, credentials, blah blah blah. Not interesting. And you have the Foreman server itself recognized. Now also, once I've booted my new host in the environment, I have all my hosts registered under. See that from here? Never mind. So there's a menu of discovered hosts. I can just see all the hosts that are being discovered, and they're also on the discovery. Here, those discovered hosts. These are all.
So the way it works, out of the box, the whole experience is supposed to be, it really depends. Foreman can be deployed in multiple combinations. The idea here was to simplify your life. So there was one assumption. We go to a Greenfield environment. Greenfield environment means you set up a separate network. Could be VMs, could be bare metal, whatever, a VLAN. You put them physically or virtually together. You put this live CD, you turn it on. Any additional machine that gets on that network automatically provision itself from network and attach itself to here.
All of those hosts were booted from your ISO.
Not ISO, from the network. So ISO only once, all the rest are automatically for PXE boot. So network boot.
Network boot will be.
What do you install?
1 second.
Host comes up
Yes.
and you are the execute?
So yeah.
Yes.
So let's go over this slide. I think it shows the story a little bit better. So I have this environment and I have the provisioning network. All the hosts are connected to the provision network, and that's an isolated network. I don't have any DCP conflicts and so on. So once I boot a host, okay, it just PXE boots from an image coming from Foreman. Okay. Now when this image comes up, okay, it has a little client. The register itself, this host itself, registers to Foreman. So in this moment, Foreman is aware of this host.
So when you think about efficient data center operations, it means no one needs to physically go to the machines, no one needs physically to open a management for the machine, nothing, all of it has to happen automatically from a single web UI or API, where you are reducing the steps for the operator who actually needs to maintain the bare metal or infrastructure.
Typical OpenStack controller.
Yeah, wait.
Without that function.
Well, we're talking about even before OpenStack runs, right? OpenStack needs to run on something. We'll get to the controller part and the HA architecture in
At this
if
point,
you give
there's
us a
no
minute.
operating system on those hosts at all.
Right, where's-
These are completely blank.
Okay.
Okay. So we go to this new tab that Stable brings, OpenStack installer, and now we see there are no deployments in this environment. I just click on the new deployment, and it brings me to this UI wizard that lets me configure my new environment, basically my new OpenStack cluster. So at this point, I can basically select the layout I would like to deploy. Okay, so I could choose, at this stage I can choose from Nova Networking or Neutron, and I can choose from a highly available controller or just a single controller. So I choose my layout. Okay, click next. Okay, at this stage I can select which services I would like to deploy in my controller. At this stage we support only, we don't support any too many permutations, but we will support that in the future. And
You support Newton GRE because don't show it.
yeah. So we can configure the service, each and every service. If there are any specific configurations we would like to have for each and every service, for example, I would like to use specific option for Neutron server. For example, GRE with specific range of tunnels. I can set everything from this menu.
By default, the default installation is over ODS.
What's that?
You install ODS drive.
Yeah. So the default layout is using OVS. Then you can choose that's VLAN underneath that, a flat network, or for example.
And again, the idea is to come with a default that makes sense, that makes you productive. You can later on go and tweak it back, change, and the system will adapt, hopefully.
To what size network do you intend this to?
This
Any
is,
size?
yes, from our point of view, this is a production grade. That means the default configuration should be with HA of all services. I think the minimum is what, 9 servers for full HA, or
So, yes,
7 or 9, I can't remember.
In terms of, if you're going to deploy 100 machines at the same time, 100 physical machines at the same time, the load on the TFTP server?
Yeah, the load itself is not on the TFTP. The TFTP itself is not an issue.
Single,
Foreman actually has an architecture, multi-network support with the ability to delegate the TFTP and installation media. So you could actually have multiple medium that you boot from, install from. We haven't really touched on Foreman much, but Foreman is used. I think the largest deployment is at eBay with 60,000 systems. And it's really all the way from 50 systems to thousands of systems, and Foreman distributes very well with its smart proxy architecture. If we have time, I'll show a bit of the drawing if you're interested later on.
So, yeah.
A lot of pages with a lot of tiny parameters. This shouts out human error.
Right.
I really want an answer file to just feed it if I do this constantly.
So the installer actually has the ability to feed, to get an answer file to feed this data. Further, we are actively, this is a snapshot of what's available today. We are actively working on even compressing that amount of data. There's a whole set of data that can even be compressed further than defined in real time. For example, when one machine needs to know about another machine, we can just query Foreman and give me what is the IP address of the HA VIP address, for example. So all of this you could later on reduce from this wizard and as time goes by. So this is on active.
Basically get to the point where it's as easy to install as backstep with an answer file.
But
then get all the pluses of managing the life cycle with
that's the goal, yes.
Is easy to install as Mirantis or maybe it will work?
All right, so I'll configure my services. I just click submit, and I've created my environment. Now, at this stage, what I can do is basically allocate hosts to a specific role, or it's called host group in Foreman. So I just selected the HA controller role, and I'm allocating the hosts to it. Just picking 3 hosts and clicking on assign. And at this stage, Foreman knows he should provision the controller node on the controller services on those 3 nodes. And I can do this for basically the roles I've chosen on my layout. So that's the block storage, Swift, compute, and so on. I'm just allocating a new compute host. And at this point, I can go to deploy and just click deploy. And what Foreman basically does is it starts the provisioning of the operating system.
Did you choose a controller right now?
Yeah, he went through and selected multiple servers as controllers.
Can you add plugins?
Yes.
Format, like Open Daylight, for example?
So this is actually a plugin to Foreman. Everything you see here is already a plugin. And it's pretty easy to add a plugin to Foreman. And the complexity here is how the plugin actually uses something that needs to be implemented. That means if you have support for Open Daylight, you need something behind the scene that knows how to configure Open Daylight actually on those systems. So it's a combination of Puppet modules that needs to be added, and a plugin to Foreman, and maybe a different answer file or something like that.
Implementation on the GUI part.
Right.
Yeah.
What-
Basically an extension to the UI that brings those specific questions you would like.
We are actually working on a plugin, or planning to start working soon on a plugin API, which will make it very easy for you and for us not to break each other, right? So this is the goal, obviously, to allow third-party integration.
Can you also install SF as a backend?
Yes, it's here. I
Yeah.
think you can go further with the screenshots a bit. So there is, I think there should have at least, if we have a Ceph. Yes,
So that's
definitely
part of
answer
the-
yes.
That's part of the module.
Yeah, it's pretty standard deployment, Ceph, cluster, and so
How
on.
do I configure the network in terms of, the provisioning network, the data network? I mean, how it's...
So at the moment, the live CD basically sets up the provisioning network and allows you to customize additional network interfaces. As you see fit, you can implement it either in Puppet itself, and then simply, this is the area where it's a bit dependent on your actual requirement and needs. And this is where the plugin stops and Foreman starts. Where Foreman is the generic framework, allows you to do quite a lot of things. The plugin is kind of a bit more specific to the things which are common for all OpenStack deployments. So it's definitely possible by adding a Puppet module that knows how to configure your networks and set up the right VLAN ID or whatever it is, depends how you actually deploy your networks.
Mostly this is the challenge. I mean, to install the packages is not...
Right, but
Yeah.
this is trivial. This is a trivial thing in Puppet land. To set up an additional network, map it to Foreman can remember the MAC address of each NIC, and then you can map the NIC to a network or whatever. You can map your own. Foreman even go the extra mile, create DNS records for you, create DHCP reservations if you do. There's a lot of things that we know how to do. We know how to talk to your IPMI devices. Quite a lot of things. So again, I'm not focusing on those, but definitely what you're describing is something trivial or common in Foreman.
So Foreman also Staples also comes with an orchestration layer. So when deploying an OpenStack setup, obviously it's extremely important to make sure that everything runs on time, right? You cannot deploy the compute before you deploy a controller, and you cannot deploy a service before you have the database deployed. So Foreman has the orchestration layer. Staples has the orchestration layer based on a project called Dynaflow. And basically what it does, it just orchestrates orchestrates the order of deployments of the OpenStack environment. So in this example, I would have my controller, my HA controller deployed first. It would first deploy the first one, then would sync all the others according to the configuration setup on the first controller, and only then deploys the compute nodes and adds them to my to the controllers. So that's Project Staypuft, friendly OpenStack installer.
Okay. Any more questions?
Feel free.
Thank you. Any other questions? Yeah. We'll do this way.
If you compare it to DevStack,
Yes.
what do you say the benefits of using accepted network?
Well, DevStack is, as you said, as by nature, is a development environment that you're supposed to set for. If you want to get closely related to OpenStack, start working with OpenStack, and not, definitely not for production grade kind of deployments. So there is a variety of tools today to help you install OpenStack. We saw Juju today, and there's Packstack, there is Fuel. There's quite a lot of different tools. I could say nothing bad about any other tool. I could only say that we try to offer a complete end-to-end lifecycle management for both low-level infrastructure like the hypervisors and OpenStack infrastructure, and also potentially for the guests themselves. Deploying the guests, configuring the guests, and all from the same workflow and management tool. Okay.
Two questions. One is with the configuration screens. When you get to the network, in the answer file, it's a special syntax in some of the parts where you need to map physical deep placement. So is the UI in Foreman still requiring you to write?
So the UI is evolving. In the beginning, it was hard-coded, put a network name. Mm-hmm. Later on, we can automatically figure out value from the system inventory.
Even if you have multiple NICs?
Yeah, so you could potentially do a drop-down because we know about each system, which NIC it has. I would assume that down the road, we'll have a nice drag and drop, but we are in active development project. So.
Okay. The other question is, during the deployment of the OpenStack image to all the servers,
mm-hmm.
so you have 10 servers that you're deploying at the same time. I mean the host machines, right?
Yeah.
You have a progress report and something that is currently continuously.
Yeah, we didn't see it, but yeah, you basically have a dashboard showing you the percentage of progress of the deployment and actual logs from each and every system, to make it clear.
You basically have a task, multiple tasks. Each task has an API and a state, and you can see the progress of the task on each system, per deployment, whatever you can call it over the API.
If Foreman crashed during the deployment, does it catch up with the
So we have a state, we have a TTL, we try, not everything, I'm sure, real life shows that even if we design it well, when you get to real life, there's always hiccups. Mm-hmm. But generally we try to design it in a way that it can resume, potentially allow you the ability to resume and continue. If possible, of course, like the answer we had before about you can't always resume.
Because you can't do that with the Packstack.
Right, Packstack is, as we said, has its limitations. It's a wrapper to Puppet at the end of the day, which runs once and maybe potentially can run again.
You want to add a chain, you destroy your system.
Right. But to be honest, Packstack started as a tool we used internally, and a lot of people saw it's useful and actually gets the job done, and then it grew for something that was not maintainable.